So let's review these tangent secant combination integrals. So remember, when we're making a good du, there's only two options: to peel off a secant tangent so that your u is equal to secant, or peel off a secant squared so that your u is equal to tangent. So remember, you always make your du first, and then you use this identity, and then how you decide of which one to use, whether to peel this off or peel this off, you always want to leave even powers. So here we go. So looking at tangents cubed, secant cubed, I'd like to leave even powers, so I'm going to peel off one tangent and one secant. There it is. So that will be my good du. Working backwards, my u is secant. So now I'm looking to see what works. So u is secant, that's taken care of. Secant tangent du, that's taken care of. Then I need to just rewrite tangent squared using this identity. So tangent squared gets replaced with secant squared minus 1. Secant squared carries along, secant tangent carries along. Now I use my u substitution, u squared minus 1, u squared du. Multiply it out, then integrate. Okay, so now I'm just going to add this multiple angle in the same problem. So first we're going to do a w substitution. So w is 6x, dw is 6 dx, so I get 1/6 dw is dx. So changing all of this from x's to w's, take out the dx, put in 1/6 dw, and everything else puts a w in there. And I'm starting off with the same peeling off a secant tangent, and that means my u is secant of w. So then I'm going to replace tangent squared of w with secant squared of w minus 1, right? Because this identity works in w's and x's. So then I'm ready to do the same thing as I did before. Substitute in, multiply it out, take the integral, and then we're just carrying this 1/6 along on the outside. So that's the only difference. So let's look at this one. So I see even powers on both of them. So I'm motivated to peel off a secant squared so that I leave even powers. So then if I'm peeling off secant squared, I move to this, I think this first. Okay, that's my secant squared x dx, my du. What's my u have to be? U's got to be tangent. Okay, so then I recognize that's taken care of. That's taken care of, and so now I know what to do to get, I need to get this in terms of tangents. So first off, I'm going to rewrite secant to the fourth as secant squared squared, because I have an identity for secant squared. So I'll replace this inside with tan squared plus 1, and then carry the rest of it along. Now I'm ready to use my u equal tangent x identity. I'm sorry, substitution. So put in tangent x here, put in tangent x here, and then here's my du. All right, so I need to multiply this out, so be really careful foiling it out correctly. Then take another step to multiply this u to the fourth in. Then finally take the antiderivative, then put the x's back in, right? The u equal tangent of x. So this one's just a little bit of a change. So this is going to be a little w substitution first. So I get dw is equal to 2 dx, which means 1/2 dw is dx. So then take the time to put the w's in, and I took the time already to peel off my secant squared w dw for my good du. So that means my u is tangent. So again, those will be taken care of. This is going to be written as squared squared. And do the same kind of thing. I'm just going to have this number 1/2 out in the front as I go through the same steps, and then when I put the u back in, u is tangent of w, and I'll put the w back in.